Hi guys, you're welcome to my channel. Today we want to commence the topic under the introductory part of calculus. And when we say the introductory part of calculus, we simply want to talk about the foundation that you need to understand before you go into calculus. And this includes the functions that you need to know before you start handling calculus. And one of those functions includes transcendental functions, which we have covered in the past, that is logarithm, exponential, and trigonometry. And if you want to watch video on that, you can check the comment section to find the links to those lectures. And in the last class, we talked about the second type of functions that we need to consider as far as calculus is concerned, and that's the non-transcendental functions, what we refer to as polynomials. So in the last class, we have talked about what? The arithmetic of polynomials, and we discuss addition and subtraction of polynomial, also division and multiplication of polynomial. So if you're looking for a lecture of that as well, you can find it in the description part of this video. It's better you understand all of these things before you go into calculus, because they will make your way so easy. So in today's class, we want to consider factor and remainder theorems. When you talk about factor and remainder theorem, what exactly are we talking about? We are talking about other ways of finding remainder or finding the factor of a given polynomial. Now, for the remainder theorem, instead of us using what? The long division method to find remainder, we want to find a very fast approach to it. So in a nutshell, remainder theorem is based by the division of polynomial. So let's give an instance. If I ask to find the remainder of x squared plus 2x minus 5. If this is divided by, if it is divided by x minus 1. So using the long division, all I need to do is to start like this. And here I have my x minus 1. Here I have x squared plus 2x minus 5. So using the long division, I need to think of a number or variable that I can use to multiply this x here in order to get the first term here. And what's that number? The number is x. X times x will give us x squared. So I have x times x, x squared, and x times minus 1 is minus x. So I can now take the difference between this and this. So x squared minus x squared, we cancelled. Then this one will become plus, because minus times minus will give us plus, and that will be 2x plus x, that will be 3x. So we have 3x minus 5. We can still divide further. And how do you do that? We think of a number that can multiply this x to give us 3x. What number is that? Plus 3. So we have here plus 3. Plus 3 multiplied by x, that will give us 3x minus 3 times minus 1, that will give us minus 3. And then we have this. So you have a minus here. 3x minus 3x cancelled. Minus times minus, that's plus. Minus 5 plus 3, that will give us minus 2. So this minus 2 is the remainder. Remainder when x minus 1 divides the remainder when x minus 1 divide x squared plus 2x minus 5. Now, let's say we don't want to use the long division to find the remainder. We can use the factor theorem, or the remainder theorem rather. So to use the remainder theorem, how do we go about it? We say, let f of x equal to the functions. What functions? X squared plus 2x minus 5. So If f of x is equal to this, remember the divisor is x minus 1. So using the remainder theorem, you let the x minus 1 equal to 0 so that you can have the value of x to be 1. Then you find f of 1. So f of 1 is going to be 1 square minus 2 into 1 minus 5. And this implies 1 plus 2 minus 5. So f of 1 is equal to 1 plus 2, that's 3, and minus 5, that's minus 2. So the results that you have when you substitute for x, that will be your remainder. And you can see you have it to be minus 2, which happens to be the same answer as when you use long division. So this is what we refer to as remainder theorem. All right, to quickly recall, under this remainder theorem, let's look for another example so that we can all understand it better. So let's take for instance that we want to divide x cubed minus 2x squared plus 5x plus 8 plus 5x plus 8. If you are to divide it by x minus 2, we are asked to find the remainder. So using the remainder theorem, what we need to do is to say f of x equal x cubed minus 2x squared plus 5x plus 8. So if this is what you have, then we say x minus 2 equals 0. Then x equal to 2. So f of 2 is equal to 2 cubed minus 2 into 2x squared, into 2 square rather, plus 5 into 2 plus 8. So 2 cubed is going to give us 8 minus 2 to the power of 2, that's 4. 2 times 4, that's 8. Plus 5 times 2, that's 10 plus 8. So this and this would cancel. Then we have 10 plus 8 to give us 18. So the remainder that we are looking for when x minus 2 divide x cubed minus 2x squared plus 5x plus 8, the remainder is going to be 18. So I want to believe that every one of us understand this now. So now that we have understand the remainder theorem, we can now move on to the next part of the class, which is the factor theorem. The factor theorem is simply the same thing as the remainder theorem, but the differentiation between them, that is the difference between the factors and the remainder theorem, is simply because the answer to factor theorem is going to be 0. So if the result is 0, that tells us the nature of the divisor. So in a nutshell, we always use the factor theorem to know the nature of the divisor. So if we want to check if the divisor is actually a factor, then we use the factor theorem. So let's see an example of that. So we have find the remainder. Find the remainder. Find the remainder when x squared minus 5x plus 4 is divided by x minus 1. So if I have these functions divided by this, we are asked to find the remainder, right? So how do we go about that? Very simple, using the remainder theorem, right? So we say let f of x equal x squared minus 5x plus 4. So if this is what we have, we can then assume that x minus 1 equal 0. Therefore, you have x to equal to 1. So we'll find f of 1, that will be 1 square, minus 5 into 1, plus 4. So if we have this, we are going to have 1 minus 5 plus 4. And this implies 1 minus 5 is minus 4 plus 4. That shows that f of 1 is equal to 0. So if f of 1 is equal to 0, because the result is 0, that simply means that x minus 1 is a factor. I hope you understand this now. So that's what we refer to as factor theorem. Now that you have understood factors and remainder theorem, the next thing we want to look at under the polynomial is what we call factorization and remainder theorem. Factorization and root of polynomial. When we talk about factorizing a given polynomial or finding the root of polynomials, we can majorly use two methods. And the first method is to use the factor theorem. By using the factor theorem, it means you want to use the factor theorem to confirm or to find one of the factor. Then you are going to use comparison to find the other factor. And the second technique or method is by using the factor method and division techniques to find the root or to factorize a given polynomial. So for us to understand what I'm trying to talk about, let's start with the very first one, that is the factor theorem. Using the factor theorem, factorize or find the roots, factorize or find the roots of x squared minus y squared. So how do we go about this? For us to be able to do this, we say using the factor method, we say let f of x equal x squared minus y squared. Then we're going to assume that x is equal to y. So if our assumption is correct, then this equation or these given functions must equal to 0. So that shows that f of y is equal to y squared minus y squared. So f of y is equal to 0. So if f of y is equal to 0, that means x minus y is a factor. Now that we've gotten one of the factor, then we can find the other factor using comparison. So if this is one of the factor, we say x squared minus y squared is equal to x minus y into bracket a plus b, where a plus b is the second factor that we are looking for. So if by opening this bracket, we have x squared minus y squared to equal ax plus bx, and y times a will be minus ay, then this will be minus by. So if you have this, you compare the first term of this with the first term of this, and the last term of this with the last term of this. So, this is the expansion. The first term of this expansion to be compared with the first term of this side, and the last term of this expansion to be compared with this. So if we do that, then we can find the value for a and b. And by getting the value for a and b, we get the other factor that we are looking for. That means x squared is equal to ax, and at the same time y squared is equal to by. So here you're going to have that a equal x squared all over x, and b is equal to y squared over y. Therefore you have that a is x and b is y. So if this is what we have, we can now write down the factors of the given function. So the given function is x squared minus y squared, and we got one of the factor before to be x minus y, and then the second factor now is going to be x plus y. So you see how we are able to factorize this using the factor theorem. But if we have that this one is x cubed instead of x squared, then we might not be able to use only the factor theorem to determine the factors we are looking for. for that reason, to make our work easier, because the only reason why we have one method for another method is just to make our work easier. So let's try the second method right now, because if you have that, probably are looking for 3 factor, you might not be able to use the factor theorem easily to get the whole of the 3 factors. And that's the reason why we have the second method, what we refer to as the factor theorem and division techniques. So let's look at that and see example on it. So let's take, for instance, that we are given a polynomial x cubed minus a cubed. If I have this particular polynomial x cubed minus a cubed, and I'm asked to look for I'm asked to factorize it, or to find the root of this polynomial, how do I go about it? Of course, you have to use your factor theorem first. So to use factor theorem, we say let f of x equal x cubed minus a cubed. If I have this, then I can say assume that a is a factor. So if we assume that x is equal to a, so we say f of a is equal to a cubed minus a cubed, and that equals 0. So that shows that x minus a is a factor. Now, if x minus a is a factor, we might not be able to use comparison to get the other factor, because this is the value, x is having 3. X is having the power of 3. That means we need 3 factors. So using comparison will not get us the remaining 2 factors. For us to get the remaining 2 factors, there's need for us to go with a long division. So that simply means we are going to be dividing the given function by the factor that we have determined. So let's quickly do that. So for us to do that, all we need to do is to start by drawing our long division table. And the function is x cubed minus a cubed. And we are to divide it with the first factor that we got, which is x minus a. So if this is what we have, we need to think of a number or variable that we can use to multiply x to give us x cubed. So we'll say x squared. So x squared multiplied by x, that will give us x cubed, minus x squared times a, that will be minus ax squared. So we have this. So this and this will cancelled, right? So we're going to be having minus ax squared, plus ax squared rather, because the minus in front of this is going to multiply this. Then you have ax squared minus a cubed. So we go again. What number are we going to use to multiply x to give us ax squared? Obviously, that's going to be a. So we have plus ax, right? Ax times x, that will give us ax squared. Then ax times a, that will give us minus a squared x. So if this is what we have again, then we can take what? The difference. This and this would cancel, and this will become what? A plus. Then we are going to have a squared x minus a cubed. So we can go again by saying what number are we going to use to multiply this to give us a squared x, and that simply become plus a squared. So if we have this now, a squared will multiply what? X. Then you are going to be having a squared x minus, then a squared times this, that will be minus a cubed. And by the time you take the difference of this, you see that your result is going to be what? 0. So if our result is 0, then we can say the factors we are looking for is going to be, remember, when we did the first one, which is this, we have x minus a to be our result, right? And when we did the second one, which is this, we have x squared plus ax plus a squared to be our result. So with this, we can now write down the factor of the polynomial. So we have that x cubed minus a cubed can be factorized as x minus a into bracket x squared plus ax plus a squared. So you see the way we are able to factorize the given function using the factor theorem and long division. I hope you understand this now. Now let's take a look at some JAMB questions to wrap this up. So when you talk about some questions on the JAMB, we are going to look at the very first question in 1993, question number 18. The question says divide the expression x cubed plus 7x squared minus x minus 7 by minus 1 plus x squared. So this is what the question states, and we have our option A to be negative x cubed plus 7x cubed minus x minus 7, and option B is negative x cubed minus 7x plus 7, and option C x minus 7, option D x plus 7. So this is going to be the very first question we are going to look at here, and you can give it a try, but if I'm going to advise you, you try by rewriting this one as x squared minus 1, and that's a very good jerk for you to get started. Thank you so much for watching to this point in time. In our next video, by His grace, we are going to start tackling questions under the polynomial, and once we are done with that, we can move to the very first part of calculus, where we are going to be discussing limits. If you are yet to subscribe to this channel, don't forget to do that right away. And if you have subscribed before, like the video, drop your comment, share this video, as it's going to benefit other people just like it benefits you. Thank you so much, guys. See you on the next one.